Today I'm talking about records and tuples, which are not about math, not about Babel. They're a new JavaScript proposal. So a new feature that maybe one day you will see in a browser. And I'm working on this at Igalia right now in partnership with Bloomberg. Before looking at what records and tuples are, I first want to tell you a bit about the problem that we're trying to solve, because you never start proposing a new feature for a language from the solution. Like, you first have to identify the problem. Well, many people prefer mutability and many people prefer immutability. We have two main ways of managing data in our application, in our programs. In the mutable way, objects mutate over time to reflect new states, and it's most used with object-oriented programming. While on the other hand, we can have values that never change, and we can copy those values, updating some parts of that. And this is mostly used in functional programming. However, modern languages, many languages, such as JavaScript, embrace both. You can use both mutable programming and immutable programming. However, JavaScript does not provide good immutability primitives. There are some very good immutability libraries. One of them, the most popular one, is probably Immutable.js. Maybe some of you already use this. Immutable.js provides some data structures parallel to the built-in JavaScript data structures. So it has maps, which are parallel to objects, for example, or lists, which are parallel to arrays. And it provides some methods to create new copies of those immutable values, changing some fields. And it provides some utilities to check if two immutable values are equal by comparing their contents, and to convert them to plain JavaScript so that you can convert an Immutable.js object to a plain JavaScript object to have it work like with other libraries. Another popular library for this is Immer. Immer takes a completely different approach. It provides a single function to use native JavaScript objects, arrays, or values in general as if they were immutable. So using this produce function given to you by Immer, you can write your code as if you were mutating an object, so with the common JavaScript syntax we're used to, but instead of actually mutating the object, Immer leaves the original map object as it is, and it gives you a new object with the values updated. So in this example, the B property of the original map object is still 2, and we have a new map object whose B value is 4. And those libraries are very good, and they let us use immutability in JavaScript in a good enough way, maybe. And there are many other libraries that try to solve immutability. However, they have their own problems, and it's not because they've been designed badly. It's just because JavaScript has some limitations, and those libraries cannot, those libraries have to respect the rules of JavaScript. One of the main problems that mostly comes up with Immutable.js is that they force you to divide your code in two. Like, the ecosystem, the JavaScript ecosystem has to be divided in two. You have all the built-in JavaScript objects with the syntax to get properties from those objects and to clone those objects. And you have, in parallel, all the Immutable.js data structures. And they use different syntax, different operations. So you cannot really write code that works with both of them. Like, if you wanted to write a function to get the name of set of properties, which might be a JavaScript object or a Immutable.js map, we just cannot do that. We have to write two different implementations. And this means that if you're writing a library or any function, we have to choose in which word we want to have it work. And another problem is that there are no language-wide equality semantics. So if, for example, we create two Immutable.js lists containing both 0 and 1, according to JavaScript, those lists are different because according to JavaScript, those lists are two objects that follow the normal equality rules of objects. And well, in JavaScript, objects are compared by reference, which is kind of like a pointer in some languages. So even if two objects have the same content, they're still different objects. However, with the equality definition given by Immutable.js, which is this is function, those two lists are the same. So when comparing two values, we always have to know according to who we want to know if they're the same or not. And this is not only about the equality operator. For example, if you're using sets, sets internally use some definition of equality. So if you use the built-in JavaScript set, it will not recognize lists with the same content, Immutable.js lists with the same content. So we have to use the Immutable.js set that will work as expected. Like in this example on the bottom right, Immutable.js tells us that the set already contains that list, while the JavaScript set cannot do that. And so every time we have to choose if we want to work with one definition of equality or with the other. And I'm only using Immutable.js for examples here, but Immer, for example, has the same problem. Well, Immer does not even provide a way to compare their immutable values because Immer just uses JavaScript objects. So you have to import your own comparison function from somewhere else. And this is a problem because there are many libraries that we interact with. For example, React, and all of those libraries have to pick one definition of equality to use. Don't worry if you've never used React. This example is not the most important point of the talk. But what React does is that it renders some tree structure to the DOM, and it skips rendering components if the parameters passed to those components, which are called props, are the same. So in this example, we're always passing the same map to the map renderer component, or at least it's the same according to Immutable.js because it has the same contents. However, according to JavaScript's definition of equality, it's always a different map because it's always a different JavaScript object. And so given that React relies on the built-in JavaScript definition of equality, it just keeps re-rendering every time instead of optimizing it. And like this is just a performance problem mostly, but there are many other libraries where we interact that use a different equality definition from what we expect. And the records and tuples proposal tries to solve exactly these problems. Before going on, please read this warning and keep it in mind for the whole duration of the talk. Like everything I'm going to say now is very experimental. We are talking about a JavaScript proposal. So hopefully one day it will be implemented in browsers, but things may change. So when it will be implemented by browsers, you might see different behavior, like slightly different behavior, hopefully, from what I'm presenting today. Okay, so what are records and tuples? They are immutable values similar to objects and arrays. They even use the same syntax. You just have to prefix them with an hash to say, hey, JavaScript, this is a record, not an object. And records and tuples are compared by value rather than by reference. So the person.colors tuple we have in the top snippet is equal to this tuple containing like blue, pink, and white that we have in the bottom snippet. And so this is different from arrays because arrays would be different here. Records and tuples are primitives, and they can only contain other primitives. Why? Well, primitives are already compared by their contents. For example, two strings are equal if they contain the same characters. This is different, for example, from C++, where two strings, like strings have pointers like objects, so two strings with the same contents might not be double equal to each other. And also with primitives, it's very easy to define what deep equality for those values mean, because primitives all have their own well-defined equality behavior, so you can just recursively apply this definition. Also, primitives work well with isolation-based security systems, where you can pass some values from one side to the other of some security isolation like membrane. And primitives are safe to pass because primitives cannot carry functions, cannot carry potential dangerous code. And also, being fully primitives, you are sure that they are deeply immutable. If you allowed you to put an object in a record, like you might have a record, you might think that it's immutable, but some property inside of that might change. Okay, I've quickly mentioned how comparison works. Let's go a bit more in detail. Well, as I mentioned, records and tuples are compared recursively. So these two records are equal because they both have an A property whose value is the same. And this value is the same because they both are tuples that have two elements, and the values of the two elements are the same. Tuples are ordered and records are not. And I believe this is the intuitive way of doing this. So tuples are like arrays, the order matters. So a tuple containing 1 and 2 is different from a tuple containing 2 and 1. For records, the order of the keys doesn't matter as long as the A property has the same value and the B property has the same value. Nonce inside of records and tuples are equal to each other, and positive and negative 0 are equal. This is probably an edge case of the language that you do not interact with much. So we try to pick the definition of equality that prevents the most problems. And you can still use object.is to distinguish between a record or a tuple containing positive 0 from a record or a tuple containing negative 0. And this is the same to how the triple equality operator works, where 0 is equal to negative 0, but you can use object.is to distinguish them. And lastly, records and tuples can be used as map and seed keys. So for example, you can have a map whose key is a pair of like coordinates in this example. You can use a tuple to have a key containing two values. And then you can use the same tuple, like a tuple with the same contents, to query the map for those values. And thanks to these equality semantics built into the language, so without having to import some other library, every JavaScript library is already compatible with this. So in the React example that we had before, React now knows that the data property is always the same, because it's the same according to JavaScript and not according to, for example, Immutable.js. Okay, so we've seen what records and tuples are, how we can compare records and tuples, but whenever we have data, those data is going to change at some point. So how do we update records and tuples? Well, we can do this in the same way as we do for objects and arrays when we try to not mutate them. So you can use the spread operator to, well, spread an existing record or an existing tuple into another one, specifying some different properties. And also for tuples, you can use all the array methods that do not change the contents of the array. So you can use filter or map or reduce or like sum and every. And I don't remember all of them, but all of the array methods that do not change the contents of the arrays are also usable on tuples. But what about the other array methods, the ones that do mutate the contents of the array? Well, there are different of them, but some of them can already be replaced by something else. For example, instead of array.push and array.unshift to add an element at the end or at the beginning of an array or a tuple, we can just use spread. And similarly, instead of pop and shift, we can just use slice to take everything except for the last element or everything except for the first element. We then have fill and copy within, that are used to update many values of the array at the same time. We've done some research about how these two methods are used, and we've seen that they're mostly used in very performance-critical applications where you need to use mutable arrays. You cannot get the same performance using tuples, changing some values in between the tuple. So we are not providing right now an alternative of those methods that works on tuples. And lastly, we have already sort, reverse, splice, and we have the setting, the element at a given index in an array. All those methods, all those 4 methods or 3 methods plus assignment will make sense on tuples. So how can we have something equivalent? We were thinking about this, and we've realized that it's also useful to have them just on arrays. Like you might want to sort an array without modifying the array itself. And so we took a step back from the records and tuples proposal, and we introduced the change array by copy proposal, which is related to records and tuples, but it's going through the standardization process by its own. So have you ever written array.slice.reverse or slice.sort to get a reversed copy of an array without modifying the original array, or similarly for sort? Well, for all of those 4 methods, we are introducing equivalent methods that do not mutate the array. So instead of array.sort to sort an existing array in place, you can use array.toSorted, which returns a sorted array without modifying the original one. And similarly, we have array.toReversed for array.reverse. We have toSpliced for splice, and we have array.width to update an element at a given index. Well, to get a copy of the array with the element updated without modifying the original array. And all of those new methods will also work on tuples. Okay, so we've seen how what records and tuples are, how to compare them, how we can create updated copies of them. I want to go back to when I mentioned that records and tuples are primitives and that they can only contain other primitives. Well, how do I reference an object inside of records and tuples? Disallowing objects in records and tuples was a decision to help avoiding bugs, because if you have some data that you expect to be immutable and then some things that change, well, your assumption that the whole thing was immutable is just going to break something. So we are happy with the decision of only allowing primitives in records and tuples. But we cannot ignore the fact that there are many objects in JavaScript, like all the DOM API in the browser, or promises, maps and sets, like even functions are objects in JavaScript. So we cannot just ignore them. Otherwise, we would risk like a ecosystem split problem where either your whole application only uses records and tuples or it only uses objects. How can we make them work together? This has been a difficult problem to solve because we didn't want to make the security guarantees the records and tuples give weaker. So what we've realized is that we have something similar to objects in a sense, but it is still a primitive, and this is symbols. Where symbols similar to objects? Well, they're similar because they're unique. Like you cannot recreate the same symbol multiple times, exactly as you cannot recreate the same object multiple times. So you can just have a symbol as a placeholder for an object, and you can have a one-to-one mapping from a symbol to the corresponding object using, well, maps. And this may seem complex, like to maintain those parallel maps that say, okay, this symbol in the record corresponds to this object, and this object was represented by this symbol. However, we expect libraries to abstract those maps away so that you don't have to think about how the internals work. You can just almost put an object in the record using like a give me the symbol function. However, this approach has a problem, and it's that it's going to leak a lot of memory because those objects and those symbols cannot be garbage collected. I'm using some words that may not be common across all the, but like some words that are not commonly found when writing JavaScript. So what does it mean to leak memory? Well, as you may know, JavaScript is a garbage collected language, which means that you create your own objects. You don't care about how much memory you are using. When those objects are not reachable anymore from your code, the browser will free the memory used by them. Well, the browser or Node.js or any JavaScript engine. The problem with putting those objects in the map is that as long as you have access to the map, you can iterate through the map contents as so all the objects are reachable, and the browser can never free the memory used by those objects. And there is one equivalent JavaScript built-in class similar to map that solves this problem, and it's weak maps. However, weak maps do not work with symbols. You can only use objects as weak map keys. So you could replace the bottom map in this slide, but you cannot replace the first map with a weak map. So it's still going, you cannot solve this memory leak, this big memory leak problem. And this is where a third proposal helps, and it's called Symbols as Weak Map Keys proposal. And just by reading the name, you might guess what it does. We can divide JavaScript values into categories, which are garbage collectible values. So values that the JavaScript engine can garbage collect, and forgeable values. Garbage collectible values are garbage collectible because once you lose access to that value, you cannot recreate the same anymore. So, for example, if you have an object in a variable, and that object is not stored anywhere else, just in the variable, and you set the variable to null or to something else, then the browser can freely collect the memory used by the object. However, if you have a number, you can recreate the same number. So you could potentially observe that the browser has garbage collected number, even if for those who know how garbage collector works, it doesn't make sense talking about garbage collecting number, but you can observe that because you can put the number in a weak map. Then the browser garbage collects it, and then you can ask, hey, does the weak map still contain that number? And if the browser says no, you can observe that that value has gone away and has been recreated a second time. So we have objects, unique symbols, and records and tuples containing unique symbols in the garbage collectible category. And in the other category, we have all the other primitives, such as strings, numbers, and etc. We have registered symbols, so symbols created using the symbol.for function, because you can recreate the same symbol if you pass the same string. And we have other records and tuples, so records and tuples that do not recursively contain unique symbols. At the moment, only objects and functions are valid as weak map keys, and this proposal extends the valid keys to also include unique symbols. You may wonder why we do not also allow records and tuples containing unique symbols in weak maps, and that's just because it's a very allowing them in weak maps is a complex feature to implement in JavaScript engines. So we are going by steps instead of doing all at the same time. It's possible that in the future, a separate proposal will propose allowing those records and tuples in weak maps. Okay, so if we go back to the example we had before with symbols pointing to objects, we can now replace our maps with weak maps, and the browser will be able again to garbage collect those objects and those symbols when they're not reachable or necessary anymore. Okay, so we've seen three proposals. We've seen the disclaimer that they're experimental, but is there a way you can use them today? Well, yes and no. So for the change array by copy proposal, which is currently, if you have ever heard about the standardization process, it's a stage 3 out of 4. So it's almost at the end. You can use polyfills such as ESCMAScript or core.js, or I'm sure that there are other polyfills for this too. And it's already shipped in a browser in Safari 16. And usually when a proposal gets shipped in a browser, it's a signal that the committee that standardizes JavaScript believes that the proposal is close enough to be the final version that browsers can start shipping it. For this symbols as weak map keys proposal, unfortunately, this is not polyfillable, and it's not shipped yet in any browser. And the reason this is not polyfillable is that it's not just introducing some like helpers or syntax sugar. It's introducing a new capability to the language that JavaScript didn't have before. And finally, for records and tuples, you can transpile them using Babel. The compiled version, if you know what Babel is, Babel compiles new JavaScript syntax to older JavaScript syntax so that it works in older browsers, or so that proposals work in current browsers. The compiled version by Babel does not behave exactly like the records and tuples proposal because it's not possible to implement the exact semantics, but it's a good enough approximation if you want to like experiment with this. And also we have an online playground. So I'm sorry for just putting a link here on like a YouTube video, but you can Google for record and tuple playground, and you will find a page where you can write some code using records and tuples. There is like a JavaScript console, like where you can see all the logs. So you can run your code using records and tuples and see how it behaves. And this is all. If you have other questions, like, well, we will now, I think, have some questions. But if you need to contact me, like for some reason, you can find me on GitHub, on Matrix, or on Twitter. And before closing, if you have any feedback about the proposal, like either if you already saw the proposal before this presentation, or also only based on what you've learned today, feedback is very welcome, because we are trying to like design a new feature for JavaScript. So knowing how developers plan to use it, or if developers are excited to use it, or if developers hate the proposal, all of this helps. It's usually hard to collect feedback because there can be a lot of feedback. But I've put this Google form. You can scan take a screenshot, scan the QR code if you have anything any comments regarding the proposal, or even if you just have some comments regarding this talk and not about the real proposal. And that's all. Thank you for listening.